So we are tasked to identify the degree of polynomial, the leading coefficient, and the constant term. But first, let's know what is a polynomial function. So a polynomial function has a general form that looks like this. So f of x is equal to a n, oh, let's write it here. So f of x is equal to a n times x raised to n plus a n minus 1 times x raised to n minus 1 plus a1 times x plus ao, or the constant term. Okay, so an minus 1 and a1 are the coefficients. Okay, they're coefficients. And n minus 1 are the exponents. An is the leading coefficient. Okay. Now, why is it leading coefficient? Because it belongs to the leading term. Okay, which is the n. If you arrange it by order, okay, from highest exponent to lowest exponent, the highest exponent is the leading term, and the coefficient of that leading term is the leading coefficient. Okay, so an is leading coefficient, and an should not be equal to 0. Okay, now why you call the exponent that classify the leading term? Now this is the degree of polynomial. Okay, the degree of the leading term. So exponent should be non-negative whole number. They shouldn't be negative with fraction, radical sign, or below the denominator. I mean, on the denominator. So now, for this, let's now find the degree of polynomial, the leading coefficient, and constant term. Okay, the degree of polynomial corresponds to the leading term. Now, if you arrange it by order, which is it is, the degree of polynomial is 2. Okay, the highest exponent. So, degree of polynomial is 2. Now, what is the leading coefficient? So, with respect to the degree of polynomial, the leading coefficient is the coefficient of that term. So, that is 3. Okay, since leading term, the degree of polynomial, the leading coefficient is on the same term. Okay, so leading coefficient is 3. Now, for constant term is the term with no variable, no x, y, or so on. So if you observe, okay, this term is the only term with no variable. So 4 is our constant term, meaning it will not change whatever the value of x is. So it's constant. Okay, so now we're done with parts of polynomial. Let's move on to types of polynomial in terms of degree. Okay, so let's draw a column. Let's label this as degree. Okay, the mean and example. Okay, so if the highest degree is 0, therefore the the name of that polynomial is constant. We called it constant. So how do we know if the degree is 0? Okay, if the polynomial looks like this, okay, it is constant because it is written as 6 times x raised to 0, and anything that is raised to 0 is 1. So we come up with 6. Okay, so anything with no variable is constant or has a degree of 0. Now, how about a degree of 1? This is now called linear. Okay, anything with a variable that's raised to 1. So, for example, 6x. This is linear because we can see it, but it's automatically x raised to 1. Okay, it is redundant to write 1. Okay, so this is linear. Now, with a degree of 2, this is called quadratic. Okay, if the highest exponent in a polynomial is 2, like, like this, this is now called quadratic. Okay, if we base on the exponent. Now for 3, this is cubic, and it looks like this. Okay, 4 looks it is quartic. A polynomial with the highest exponent of 4. With 5, that is quintic. A polynomial with highest exponent of 5. Looks like this. Now, from 6 high and higher, we called it nth. Okay, from 6 above, that is nth or nth or nth polynomial. Okay, so nth polynomial looks like this. So anything more than 6 is nth polynomial. So that's basically it. Okay, now let's identify the end behavior pattern of a polynomial. Okay. So what if we have this? Negative 3x raised to 9 minus 4x minus 2. Identify and behavior pattern. Okay, so the end behavior pattern is the pattern of the graph. Okay, if you have a graph that looks like this, then the end behavior of the end behavior of this graph is going down to left and going down to right, or it goes downward. Okay, now if we have a graph that looks like this, okay, then it is rise to right and going down to left. Now that is the end behavior pattern. Now how do we identify the end behavior pattern? Just by this polynomial function. So we can find it with these simple rules. So we base on the leading term, okay, especially the leading exponent and coefficient. Okay. Now, if, for example, a leading term is positive and raised to squared, the end behavior pattern is upward or both upward. Okay. If the leading term is, or the leading exponent is an even, okay, and it is negative, then instead of both upward, this will become both downward. Now what if the exponent or leading exponent is odd number, like 3, 5, 7, or 9, okay, and it is positive? So this time, from to left, it will go downward, okay, but to right, it will go upward. Now, if it's negative coefficient and odd exponent, we will reverse the pattern. Okay, so from right to left, it would rise, okay, and to right, it will down or sink. So that is the behavior pattern. Now, which of these do negative 3x9 what do you call this? So which from these do negative 3x9 agree, okay, based on negative sign and the exponent? So first, we identify the exponent. So that is 9 and that is odd. So we have these two, okay? Now we have negative leading coefficient here. Therefore, the end behavior pattern of this function is going rise to left and down to right. So this is the end behavior pattern of this polynomial.